Hi everyone, I'm V. This is functional DevOps in this dysfunctional world, and the reason it's like that is because if I put all the words like on the slide in that font, then just my name drops off. So and it's very important that you see that. Feel free to like follow me on Twitter or whatever. But let's begin. So the background about me that's relevant to this is that I used to be a web developer before I got my current role. And when I was a web developer, our DevOps, because we had to deploy systems to production, right? It's part of what you do as a web developer. As most jobs, you have to well, what I would have to do is I would have to SSH onto a staging server and do a deployment. So which for us meant do a git clone and then do a migration, run the migration manually, like go on the site, check that everything's okay, and then write down all my instructions as I was doing this, so that someone else or like me in the future could go and do this in on the production side. And as you would imagine, this is not ideal, right? Like sometimes I'd forget to write something down. Sometimes production would be different from my staging environment. Things would just go wrong like a lot. It was pretty awful. And for a bunch of other reasons, I kind of like got really sick of it. And I was like, you know what? There has to be more to programming than this. So then I discovered functional programming. Like I rediscovered functional programming, and it's been like really, really awesome. And so one of the reasons I was excited about becoming a DevOps engineer afterwards is because although like DevOps is an interesting role, the stack that I get to work with is functional. And I'm going to show you what that means. But before that, I'm going to give you the DevOps pitch. So why do you care about DevOps? I'm assuming that you're somewhat interested. But even if you're not, like, what's the point of DevOps? So in my mind, like I contend that the point of DevOps is to remove this. Is to remove this sentence from like everyone's like lexicon. No one has to say it, no one has to hear it. Everything will be great forever. Because when someone says it works in my machine, what they're saying is my system is somehow different from someone else's system. And if it's broken, it's like, it's not my fault. But like DevOps is supposed to empower you to fix the problem, as opposed to, just saying that it works on my machine. And the other thing about DevOps is that, your work as a software engineer, as a maker of software doesn't end when you write a line of code, do your like git commit. Like it's not, the work's not out of your hands, because as soon as you do your git commit, it doesn't mean that your software is delivering value to your customers. It's not in front of them like doing things. So something has to happen between you doing your git commit and your git push and like the code ending up on your user's computer, whatever that means, or on a server that you control that your user can access. So that's DevOps. So what are the things that I want out of a DevOps process? One thing that I want it to be automatic. So I'm going to contrast this to my experience I was telling you about doing my git clone and my my manual migrations and going and like seeing things break. And so it has to be automatic. If I have to do a whole bunch of steps, then I have to like write them down, I have to do them in an order, things can go wrong in the meantime. It needs to be automatic. It needs to be like one command, not more than one command. It needs to be repeatable. So like I said, my staging environment and my production environment are slightly different. So sometimes even if I did everything right on my staging environment, things would break on the production environment. So I have to be able to do it, and like at scale, this is not going to work. When I was a web developer, we had there were like 5 or 6 of us, and we had like small clients. We had some big clients, but mostly small ones. And this is small by Australia standards, which is like really small. So repeatable means that like now we serve like thousands of customers. It's like thousands and tens of thousands of customers. We have to be able to like spin up servers repeatably like every time. You have to be able to like do something to a server, do something to another server, and the two servers have to be like functionally identical. Like it's important. It's not good enough to be able to like SSH manually in and run a bunch of commands. It's just not going to work. So this is not, I wouldn't say this is strictly required, but this is something that's really nice. It's really nice to be able to like try to deploy to a server, and the server is like, hey, I'm already in the right state, and no work needs to be done. Because if you have to do a whole deployment process from scratch every time you want to deploy to a server, it can be very, very slow. So it's good to have an idempotent process, so you're not doing unnecessary work. It makes your deploys a lot faster. And this is the thing that I would have assumed like a few months ago is almost impossible. But it's nice to be able to deploy and go, hey, I've made a mistake, I made a horrible mistake, because I make mistakes. And it's nice to be able to roll back. It's nice to be able to say, okay, this is a mistake, let's roll back. And with most deployment process, at least the one that I did before, it's like, how do I undo like my migration and my git pull and like the site, and like almost impossible, but not anymore. And this is another nice thing. So it has to be atomic. So if I do a deploy, the user should not be able to visit the site somewhere in the middle of my deploy and see a broken site. I don't want a broken site. The site should be working before and it should be working after. And the user should not be able to observe any state in between. And in fact, so when I was looking at my old DevOps process, my old process of like doing my git clone or whatever, I was reading about it, and someone was like, hey, someone on the internet was like, hey, what you should do is you should git clone to another directory, and you should symlink that directory over and like switch the symlink. Because the interesting thing about symlinks in Unix is that symlinks are atomic, which means that the user, like the system, will not be able to observe a state between like the old target and the new target. So symlinks are interesting. So they're one of the few things in Unix that is guaranteed to be atomic. And I'm mentioning this now because I'll come back to it a bit later. But anyway, atomic deployments are really, really good. So I start with a tiny web service. This is a tiny Haskell web service taken straight from the Scotty package documentation. It's pretty straightforward. I called it Bank Me Up because I'm really good with names. It takes the it takes a single parameter and puts it in between the words Scotty, bank me up, and that's why I called it Bank Me Up. So that's the app. That's the Kabbalah file. It's very straightforward. The only dependency is beyond base is Scotty. And then the Nix stuff starts. So I'm gonna like demonstrate this, but so I'm gonna demonstrate this. I was gonna say I'm not sure if I should do it like before or after, but maybe I'll just do it like alongside. Okay. Can everyone see this? Okay. Yeah. Okay. So I do so. Yeah. Okay. So wait. I think yeah. So anyway, so then I can do a Unix build, and it should compile, and it'll build and compile the. So Nix build without any arguments is going to automatically by default look for the default.nix file. So it's going to do that. It's going to give me some build output. So anyway, it's giving me that app. So then I can do, so this is a path in the Nix store, which is kind of like a Git repo, but it's also symlinks it to my, to a file called, to a link called result in my current directory. So as you can see, these are the same path. So then I can do result. Okay. So then anyway, so I did that. That's interesting. Okay, so I would expect that to be bigger. Yeah. So I set it to be 3,000. Yep. So it's running and it works. Okay. So the interesting thing here is that I haven't interacted with GHC or Cabal or any of the Haskell tooling. There's literally one where I ran I ran commands that have there's absolutely no interaction there. So, and that's one of the value propositions of the Nix ecosystem is that if you have the tooling set up, the appropriate tooling set up, you can be almost language agnostic. You can deploy a Python app in the same way, or an Elixir app or a Node app or a Rust app or anything, and it'll work. And you don't really have to think about that. So okay, so I've deployed my service. Oh, actually, there's probably one thing there's one thing I do want to mention. So suppose I have an app, and I break it. I put something nonsensical in there. Yep, and then I build it again. What do you expect to happen? Anyone? Just gonna wait until the computer tells you. Okay, so it's failed, which is, makes sense, right? It should fail. Like, it would be weird if it succeeded when I broke the app. But but my result file still exists. Yeah, that's a mistake. So so it still exists, and it points to the same place that it did before. So Nix actually, as part of building an app by default, it will run the tests for the app, it builds things in phases. But this app doesn't have any tests. But because the build failed, it won't like get to the end, and because it won't get to the end, it won't switch the symlink over. So if I have a working app and I try to like break it, then my stuff will still continue to work. So it'll fail gracefully. Which is good, which is what you want, at least, when you're like when you're trying to deploy something. So that's good. So I'm going to unbreak that app now. And move on to the next bit. So this is the first bit of Nix that I'm going to show you. So Nix is also a programming language as opposed to like a package manager. And I cannot only use it to configure, like, to build my app. So it's useful even if you don't run NixOS or whatever. But if I'm running a NixOS, which is an operating system that's fully configured with Nix, then I can also use it to define a service. So a service is like, long-running program. So this is like, if you're just running a one-off executable, you can use Nix on macOS or on Linux or any Linux or almost any Linux distro. But if you want to use it to configure like a systemd service, Nix allows you to do that, but only if you're running NixOS. So this is like the skeleton of a service. So this is Nix. What Nix looks like. This is basically a lambda. This is an anonymous function. It takes an attribute set, which is what Nix calls like a dictionary. The dictionary has key value pairs, and this is like basically this is a set of arguments, and this is like dependency injection. So this is the configuration for the whole system. This is the Nix library of functions. This is an argument called packages. It has all the packages available to me, all the packages Nix knows how to build, and this is just any extra parameters that I want to pass in. And what I'm going to do is I'm going to define another attribute set, and the attribute set has two attributes. One is called options. One's called config. So this is the skeleton of that. That's what it looks like. So the first thing I want to do is I actually want to make my binary or like my executable available to me. And the equivalent of the Nix build that I did before in Nix itself, in the language, is packages.call package. So I'm going to so now I have blank me up, which is the app. Then I want to have an option, like I don't want the service to be enabled all the time. I want to be able to configure whether I have it enabled or not. So first thing I do is that I have an option called enable, and if it's set to true, it'll be enabled. If it's not set to true, if it's set to false, it'll be disabled. And there's a config that is only active if the service is enabled. And okay, so this is the meat of the thing. So if it's enabled, I open the port 3000 that I specified earlier, and I define a systemd service. So I don't know how familiar you are with systemd, but this is more or less the same as some of the keys are the same. Exec start, restart, kill mode are the same as what you would get if you wrote the systemd unit file by hand. And I'll demonstrate this to you later. I'll show you like what the generated systemd file looks like. But for now, just trust me that this is the systemd service. So far, what about this is functional? The a build in Nix is referentially transparent in the sense that if you build something and you build something and then you rebuild it again later and nothing has changed in the inputs, the output will be exactly the same. In fact, Nix won't even perform the build. It'll say, hey, this is the same stuff I was asked to do before. I'm not going to do it again. In fact, I can show you this. So if I do my Nix build, it should not rebuild. Oh, I made a mistake. What did I do? I did, but no. But that's what I mean. Like the point is that when I unbreak the app, when I built the unbroken app, and then I broke it, and then I unbroke it, the unbroken app is exactly the same as the first one, so it shouldn't rebuild. So I made a mistake somewhere. Let me just figure out, because it's important to me that you see that this works. Oh, that's very strange. What? Yeah, there's probably a space in there somewhere, but I don't think so. Yeah, I'm not sure. Anyway, just Yeah, just build this twice, which is very strange. No, there's something else that's going on. Right. Oh, no. So because that's not in the right. Okay, let me see if. Oh. Okay, that's why. So I have all these like stray files that my my silly editor is putting in here. Okay. So anyway, so this what this means is that my first build was also kind of off because I got it wrong because it had all these temporary files. But I'll demonstrate because I'll build this once and I'm going to build it again, and the second time it won't do any additional work. So okay, so it's going to build the first time, but wait, just bear with me for a sec. It should be pretty fast. Okay, so I built it once, right? Then build it again. Yeah, it doesn't build. It doesn't build again. It says, hey, the input's exactly the same. I'm not going to do any extra work. Okay, so we do that. And should probably disable neomake because it's really annoying. But anyway, so it's referentially transparent. And I'm not actually doing any I/O here. I'm like specifying the inputs in a declarative fashion. And it's building it and it's putting it in the next store. I'm not actually saying, hey, output this stuff to the screen or create this file in this location that I control. Everything, like all the outputs are in the next store. The only thing I've declared is I've declared a service, and that's not, yeah. So in that sense, it's functional. If you go to the Nix webpage, which is nixos.org/nix, it'll probably tell you that it's the purely functional package manager. So they're thinking along the same lines. And okay, so I've defined a so okay, so this is where I so in a minute I'm going to show you that the systemd unit file that I generated, but until then, so I created a file called I created a new folder called ops, and I put my service file because I import my service, and I enable it. So after I do that, I can demonstrate that that I can show you the generated systemd unit file. So this is something that I stuffed up the last time I did this. I'm just going to try to not get it wrong. This is very hard. This is you would not imagine how hard this is. But anyway, okay. Yeah, computers are hard. Yes. So do that. So anyway, the point is that this is something that like evaluates. This is basically like it interprets a Nix file and spits out basically what the system unit file is. And you don't need to know this command. You can look it up if you need to. It's not important. But the point is that I can like run it and it'll actually output the file, the contents of the file that I expect. And this, if you've used systemd, this is relatively familiar. And yeah, the only difference is all these weird like SHA-256 hashes everywhere. And that's basically how Nix it's kind of like a Git repo. So instead of a SHA-1, it has a SHA-256, and Nix puts the name of the thing that it's hashing at the end, so you know what you're referring to if you like really need to look at it, which is really handy actually. So okay, so I have my system unit file. Oh, what did I do? Where did it go? Okay. What? Yeah, I undid everything. I have to start this presentation all over again. Oh no. Okay. So so then I created another file called trivial, and I call these files trivial because I looked at the Nix ops manual before I gave this talk, and they also called their stuff trivial, and I basically took their files and I changed one or two like small things. So basically the only thing here is that so I enabled rollback, which I'm going to demonstrate to you later, and but this is pretty much the same. So what I do is that I basically create a VirtualBox environment with a gig of RAM, 2 virtual CPUs. Nothing too fancy. And now I'm going to actually like deploy the service. I'm going to deploy it to VirtualBox because deploying it to AWS is possible. NixOps has a lot of backends, so it has it has backends for AWS, GCP, Hetzner, like a whole bunch of other like interesting backends. But those require talking over a network, and I didn't want to like make you wait for that to happen. So so I'm already in the right directory. I go NixOps. So I show you that there's no deployments that I have yet. So I'm doing this straight from I'm going to copy all these instructions. Okay. So nixops create. So dash D is short for dash dash deployment. So if I create my trivial deployment, then I should be able to deploy. So it's going to take like a minute maybe, because it's doing it from scratch. Yes, I'm curious what this looks like from your perspective. Okay, so what it did is that it spun up my VM in VirtualBox. Now it's waiting for the SSH service to start, so it can talk to it, or maybe it's waiting for the IP address and then it'll wait for the SSH service. No, it's not going to take very long. This is why if I were doing this over the network, it would take a while. But because I'm doing it on my machine, it'll be fast. It shouldn't take more than more than a few minutes. Why is it? That's a good question. So when I was investigating this, I found out that, so you'll see up here it says 1609. So what that means is that NixOps, for whatever reason, hasn't built like the latest version of NixOS to like put on the system. So what NixOps does is that it creates a NixOS virtual machine with a certain version of NixOS on it, and it copies everything that is different between what you want and what it has, right? And the version that it starts up by default for whatever reason is 1609, which is like more than a year old. Instead of 1709. So if it copied 1709, it would be a lot faster. But in the time it took for me to explain that to you, this is done, and it's almost finished deploying. So yeah, so I did raise an issue. Like I put it. NixOps is like a GitHub project and has GitHub issues, and I was like, hey, why don't you guys use 1709? And they're like, that's a good question, and then you haven't done anything more. So maybe soon they'll have a newer version of NixOS as a base image. So okay, so it's deployed. So the IP address is 56.101, right? 192.168. So I should be able to do that. So port 3000. What's your favorite word? Shoot. Okay. Whee! Okay. That's it. Like I deployed it. See, that was pretty straightforward, right? Great. So I've deployed it, and it's done. So what about this is functional? So again, I didn't do any I/O until like the very end. I was not like saying, hey, you should put this file in this machine. I was saying, hey, these are the services that I want to be available. Then I did my one-line deploy, and it copied everything over, and it did my deploy, and I can like show you that it's working. So it's functional. It's great. It's declarative, if not functional. So this is great, right? We can all go home. Like my work as a as a DevOps engineer is done. I don't have everything's just going to keep working. Everything's great. There are no problems with anything, except there's a problem with the app, and I can point it out to you. That. So don't know if you so as a if you're like deploying a web service, you don't want to hard code the port. It's not a good idea, right? You want the port to be configurable, because what if you want to run two different versions of the service on the same machine? What if you want to scale up and you want to like run another service? Like you want to run this on a bunch of machines, and not all of them have that port open. What if you want to run something whose port conflicts with this one? So 3000, like, it needs to be configurable. It's just not good enough that it's not, right? So what I do is that I go to the devs, because I'm not the person who wrote the service. Let's pretend I'm not the person who wrote the service, and I go to my devs and go, hey, I need you to make the port configurable for me. and they go, nope, sorry, we're too busy. Too busy working on version 2 of the app. It happens, right? And like, this is a contrived example, but sometimes, there are problems that even they don't really know how to fix. And in the meantime, you have to kind of work around them. You have to do something in order to fix the issue for the time being, so you can go to sleep and you don't get pinged at like 3 a.m. Because that's the thing that happens when your systems just aren't configured correctly. So one thing you can do with Nix is you can patch services. So Nix builds things in phases, and one of those phases is a patch phase. And although you can just supply like a patch file, you can put everything in one file and go, this is the post patch phase. So after Nix applies any patches that it needs to apply, I can say this is the old thing that I had, and this is the new thing that I had, and I can like just replace it. I can substitute it in place. It's really good. Well, no, I'm not. This is yeah. I mean I'm not. I feel great. This is awesome. I'll show you. I will show you. Wait. So I mean, this is obviously to reflect the fact that this is a hack. This was a hack, and when somebody gives me a fixed service, then I will switch it out. I can remove it. It's fine. It's not a problem. And because this is all happening in Bash, these are all commands that are being run in Bash. I'm just gonna cap the file at the end, so you can see that it's working. So then I go back to my other directory. You can, yeah, you can supply a proper patch file, but the problem with that is then I have to show you a patch file and I have to show you my Nix file. In this case, I can just put it all together in one file, and it works just fine. Yeah, I have.
Why not to use come-up configuration variables?
I could do that too.
Because then you just want to Haskell file.
Yeah.
Configures the configuration.
Sure. You can. There's lots of different ways to do this. I was thinking another way that you could do it is that I could write a patch that at like build time it'll take the configuration parameter that I configure in the service and then it overwrites that. So there's lots of different ways to skin the cat. But the point is, at some point you need to be able to like touch code that isn't yours. You need to be able to patch code that you're not necessarily like the owner of.
Yeah. So if you just give the
yeah, totally, you can do that
on the command line of
exactly. So nobody's like that, but yeah, that's another way of accomplishing the same thing. You're like you're kind of injecting code in at some point. So anyway, let's do that. I'll show you how that works. Sorry? Yeah, I will have a default, don't worry. Yep, so anyway, you can see I patched it, sorry, as expected. Yeah. And I have that. Okay, so show you this working on 3001. So yep, it works, right? So I've accomplished my goal of patching the app, but I actually want to deploy this patch service. So the first thing that I want to do is I want to update the service to have another configuration parameter with a default in case I forget to apply it. So I have another, so I have a port, and then everything else is almost the same, except instead of opening port 3000 with the firewall, I need to open the port that I've configured, and I need to supply it to my command line. To do that, my web service is almost the same, except I import the patch file and I provide a different port. So I'm just going to do this in front of you, and then I So is everyone okay with is port 3001, or does everyone want me? Do you want me to use a different port? 1337? Yeah, let's do that. Sounds good. Assuming it's open and nothing else is using it. Okay, is that it? Is that all I had to change? I think so. So now I can do. This will be a lot faster. It's not going to copy over 2 gig of stuff. just my changed service. Yeah, done. Okay, so same thing with my curl. Great. What's everyone's favorite verb? Give me a verb. Patch. Okay, great. It works. Isn't that great? I don't know about you guys, but this like blew my mind the first time I did it. I was like, oh, this is so easy. And not only is it really easy, Nix also makes it almost trivial to roll back. So, like I said, I make mistakes. I can go, oh no, I've done something's gone horribly wrong. This is it's as easy as this to roll back. And the number is the generation. So like the one basically is the first deployment. So I do that. So I do the thing that I did last time, and that doesn't work because 1337 is not the port anymore. But I can do. Okay, give me another verb. Anyone? No? Yes? Okay. Jeez. Tough crowd. Okay. Yeah. So that's that. And so in summary, Nix is a package manager, so you can use it on macOS as well. I would say it's on the same order of magnitude as Homebrew in terms of the software that's available for it. So you can use it on macOS. It's very useful on Linux. Even if I have a laptop that runs Ubuntu that I use Nix on for a whole bunch of stuff, and it's really great. It works really well for like just building stuff. Yeah, it's a great build tool. It's a great environment tool, so you can use it as like a cross-language replacement of like virtual and Cabal sandboxes, Ruby and like just almost anything. And it's a programming language that you use to build and package software. It's Turing complete. They like really like to use this idiom where they recurse, like there's like a fixed point and they recurse. It's a lazy programming language. I forgot about that. So that's a similarity with Haskell. The lazy functional programming language. So it's really good like for that. NixOS is an operating system built on Nix. This laptop runs NixOS. Most of our customer-facing servers run NixOS. Very useful. NixOps is a cloud deployment tool. So it's a replacement for like Puppet, Ansible, like a whole bunch of stuff. And you don't really have a lot of issues that you run into when you're using those tools. And DevOps with Nix. So how is it automatic? Just one command. Like I ran one command, it did the thing. I don't think that's much easier than that. It's repeatable. Yeah, if I wanted to do this on like 500 machines, it would be just as easy. It's idempotent. So if it's in the right state, it like doesn't do any additional work. In fact, even when it was rolling back, if you notice, it didn't really copy stuff over. It was just like, hey, I'm gonna go back now. I'm like, okay. It's atomic, so nothing will like. Because everything, so what Nix does when it does a build is it builds like a whole tree of symlinks pointing to parts in the Nix store, and it swaps over a symlink like right at the top. So from a system's perspective, the system can observe anything in between. If you're doing like a whole bunch of machines, you might want to have a ELB set up. Like you want to have like a load balancer that you take each machine out, you upgrade it separately, and then you put it back in, so that a user will not be able to tell. But that's not really like. I don't think that's a concern of like NixOps, and Nix itself is like does atomic deploys, atomic like upgrades and stuff, and it's as functional as I've demonstrated. So that's it. That's really all I have for you. Questions?